Random numbers in computer programming are especially useful for doing things like games, simulations where we're maybe flipping a coin a certain number of times, or doing some unit testing. Python does not generate random numbers in and of itself, so we have to import a class called the random class into our program. Then we can use the methods of that random class to generate random numbers. Now, we'll point out that technically Python does not generate true random numbers. It generates what we call pseudo random numbers, in that it generates a very long list of floating point values between 0 and 1. And then it uses those values in producing the range of random integers that we might want to use, or in calling random float values. So here's how we generate an integer randomly. Once we've imported random, we might have a variable such as number 1 to 10 equals, and I call random dot, and then I call the randint method, and I put two values in parentheses that are both integers, comma separated. The first is the lowest value and the second is the highest value, and these are inclusive. In some of the languages, the higher value is not always inclusive, it may be exclusive. So this would generate a round number between 1 and 10. Now if we were creating a game and we wanted to simulate rolling a pair of dice, we might have a variable called dice1 equals random.randint 1, 6, and that would generate a number between 1 and 6. Same way in doing a card game. We might have a variable called selected card, and it's going to equal random.randint, and here we're going to go from 1 to 52. So 52 possibilities. And again, these are integers. If you wanted to have a random floating point value, there is a method for doing that with random. So my float equals random.random. It's just the random method, and we don't need to put anything in parentheses, and it will generate a value between 0.0 and 1.0. And I think it's about 12 or 15 decimal places. Now, the numbers that are generated are seeded by the system clock, and it's based on the millisecond value of the system clock, I think generated since like 1970. Unless you ran your program at the same time on two different computers where the system clock was identical within a millisecond or 1,000th of a second, is how you would get the same random numbers. Otherwise, they're going to be different. Now, we can also seed that random number generator. So rather than using the clock, we can give it an integer value. So here I have random.seed 1, 2, 3, 4, 5, 6, 7. And it would take that value, place it in the algorithm, and generate that list of random numbers that would pull from. So this might be useful in creating a game where you randomly maybe even seed the random seed generator, but you keep track of that number. And let's say they're playing a solitaire game and they don't win, but they want to play the same game again. Then with that random seed regenerated, you can get the same listing of cards or same order of cards in that solitaire game. Well, let's take a look at how to do some of this in Python itself. Here in Python, I've created a new file called randomnumbers.py, and I'm going to first of all import random so we have access to those random methods. And then I'm going to print randomly generated numbers between 1 and 9. So just header information for what I want to print, or what I'm going to do in this little application. We're going to generate random numbers between 1 and 9. And we're going to use a for loop for I in range. And I'm going to go from 1 to 5. So we're going to generate 4 rows. Remember that last number is exclusive. So I is going to go from 1 to 4, and then it'll kick out of this loop. And in the loop, I'm simply going to print random.randint. That was our method. And we're going to do a number between 1 and 9. And I want to print a few of these. So I'm going to basically just copy this. I'll do a backslash to carry this down on the next line. We're going to print out 5 of these. Okay, so that's my program. We're going to get 4 rows of 5 numbers between 1 and 9 that are randomly generated. So let me run this. And there are our 5 numbers: 15733, 58865, 59529, 69477. I'm going to run this again, and I get completely different numbers, and I'll run it a third time, and again, completely different numbers. Now let's look at the impact of seeding that random number. As I said, I rarely would ever seed the number unless it was a special case where we wanted to be able to use the same numbers again or play the same game again. I'm just going to put in an integer, kind of at random here, 8720934, and now I'm going to run my program. And so I get 29115 and so forth. Let's run it again, and I get the exact same numbers because it's seeding that list of numbers that it randomly generates and that I'm then using in the randint method calls. I'm going to comment that out. I'm going to add another line here, and this is going to be print. So what I'm going to print is random, and I want that method call. So this is a string value, but I'm representing that we're calling that random method, which generates a floating point value. So we'll say it generated. I'm going to do a placeholder of 0. And then we're going to format random.random method. So it's the random class.random method. And a closing print and another closing print. So I have the same number of right parens as I have left. Do a Control S to save, F5 to run. So now we're getting our 5 randomly generated numbers, or 5 rows of randomly generated numbers from this. But here we're seeing that value that's printed out. Random generated 0.6434239964488303. And I said I wasn't sure how many values there were there, so it's actually 16 digits that's being generated after the decimal. Rarely do I use floating point values in anything that I'm doing randomly. It's almost always integers, usually in response to playing a game, rolling a pair of dice, drawing a card, generating integers, maybe in a mathematics flashcard example, where we're going to have a student add 2 numbers together that are randomly generated. Those are all going to be integers that I'm going to do. So randint is used by me, at least, far more than I would use random. So I want to randomly generate a number, an integer, that contains the digits 1 through 7 in random order. So there'd be some examples. Okay, each one's going to contain 1 through 7, but the digits randomly ordered. So I want to basically build this string of these 7 digits without any one being repeated. So how can I do that? Well, if we only had one number, only wanted to use one of those 7 digits, we could simply say a equals random.randint 1, 7. That's going to generate maybe a 2, maybe a 4, maybe a 6. So that's going to be our first digit. Then I'm going to generate the second digit using the exact same method, but I'm going to place it into a variable called b. So each of these will be integers. They'll be 1-digit integers. So that first one might be a 2, and the second one might generate a 6. But it might generate a 2. I don't want to have both of these be 2, so how do I take care of that? Well, we can say while b is equal to a, I'm simply going to regenerate the value of b. And I'm going to do that same method on all of the other digits. I'm going to copy this, and we're going to generate a C. But I don't want the C to be the same as A or B. So while C is equal to A, or C is equal to B, I'm going to regenerate the value of C. That will give me 3 unique digits. Now I need a fourth one. This one's going to be digit D. And so I want to repeat generating that random D value if D is equal to A, or D is equal to B, or D is equal to C. And if it's any one of those, we'll regenerate D, and we'll keep doing that until it becomes a unique value from A, B, or C. We're going to do E. And once again, we're going to do it while E is equal to A, E is equal to B, or E is equal to C, or E is equal to D. And we'll regenerate E. Got one more to go, 2 more to go here. So this one's going to be F. And we'll do this while F equals A, F equals B, or F is equal to C, or F is equal to D, or F is equal to E. And I'm missing my colon. And so while any of those are true, we're going to regenerate F. One more. Copy that. This one's going to be G. This will be our 7th digit. And we're going to generate it while G is equal to A, G is equal to B, G is equal to C, G is equal to D, G is equal to E, or G is equal to F. And then we'll regenerate G. So these sequential while loops allow us to create a digit between 1 and 7 that's unique to previously generated digits. And we're going to put those 6 digits together in a print statement. We use 6 placeholders, 0 through 6, and then we use our dot format. And what I'm going to format here is A, B, C, D, E, F, and G. Let's run this. So again, we're getting our first loop with those 5 rows of 1-digit numbers. We're getting our floating point value randomly generated. And here, my randomly generated sequence is 4, 5, 6, 7, 3, 2, 1. Contains all 7 of those digits. Well, let's test this a few times. And what I'm going to do here is I'm going to comment out this top loop so we don't see it run again. I'm going to comment out that region. And then let's put this whole thing inside of a loop. So we're going to say for I in range, let's generate 15 rows. So I'm just going to do from 1 to 16. And then I want this to all be indented. So I'm going to go to Format and Indent Region. So now everything's occurring in this loop. And we should see then 15 randomly generated values, each with the digits 1 through 7 in random order. And there we go. So each one of these numbers, pick one at random here, has the digits 1, 2, 3, 4, 5, 6, 7 but they are ran in a random order. And there's a chance, very slight chance, especially with only 15 values, that you would get the same number twice. It's basically going to be 1 in 7 million that you would get two numbers the same. Let's look at another way we can basically do the same thing. And again, I'm going to comment all of this out. So now I want to do a value that's 10 digits, 0 through 9. So I'm going to create a string value called 10 digit. It's going to equal nothing. So quote, quote, null string. I'm going to create a loop for I in range 0, 10, colon, digit equals random.randint 0, 9. And then while we can take the string value of digit, because it's an integer, while that is in 10 digit. So the first one, there's nothing in 10 digits, so that's going to be a false statement, whichever number we generate. And then in that while loop, if that is true, if it is in 10 digit, then we'll simply regenerate digit random.randint. And again, we're going to go 0 to 9. That 9 is inclusive, where our range, the 10 is not. So we're going to generate 10 numbers between 0 to 9, or go through that loop with I being 0 through 9. And then, once we find that digit that's not part of 10 digit, we're going to add it to 10 digit. And we'll add it as a string. So we're going to take the digit value. Once we are all done with our for loop, we've generated 10 digits between 0 and 9, we're going to print random 10 digit is, and I'm going to use placeholder 0, and we're going to format then 10 digit. Now I'd like to see that happen a number of times, so as we did before, let's create another loop for x in range. And again, we'll do 15 of these. So 1, 16, colon. And I want to indent these also under that statement inside that loop. So now this is all going to occur in that loop that runs 15 times. We've commented everything else out. I'm going to save, Control S, F5 to run. And there are our 10 digit values now. Everyone has a 0 through 9 digit in it. If you wanted to create some type of Sudoku puzzle, randomly generating the numbers, this would kind of be how it would be done. And there you have to figure out the 1 through 9 in each block, as well as the 1 through 9s going across and down. Well, what if we want to do the same thing with letters? Maybe we want a sequence of letters from A through L that would be randomly unique in their order. So we can do it the same way. So I'm going to say letters equals, and what I'm going to do is just create a string of those letters that I want to use. So A, B, C, D, E, F, G, H, I, J, K, L. And then I'll create another string called randomly ordered letters. And this can equal a null string. And then again, we'll do a loop for I in range. And my range here is going to go from 0 to the length of letters. And that needs to be a comma and not a period. Now, by using the length of letters, remember we start counting with 1, where the indexes start with 0. So this is going to be the last index of the last letter. And that works out perfectly then, because this is exclusive. It's going to be a loop, so I need a colon. And then I'm going to create a variable called next letter. Let's do a capital L on that. Equals, I'm going to say it equals an asterisk. And the reason I'm going to do that is I'm then going to create a loop that says while next letter is equal to a string of an asterisk, which means it's going to generate what's in the loop. Index equals, so we're going to randomly generate the index number, random.randint, and again we're going to go from 0 to the length of letters. In the randint method, that is inclusive, so we'd be outside of the range of the number of letters, so I need to subtract 1 here, so minus 1. If letters subindex, and that index will represent whatever letter. So if we generate, say, a 4, well, index 4 would be letter E. Remember, we start counting with 0. So A is 0, B is 1, C is 2, D is 3, E is 4. So if E does not equal, or the letter in the 4th character is not equal to an asterisk, so then next letter is equal to letters, and our index would simply be the value of index. Randomly ordered letters, then we're going to concatenate to that the value of next letter. And again, I want a capital L there, next letter. Letters is going to equal letters, and my range is 0, colon, index. That's going to take all the letters in front of that index value, plus we're going to replace the letter we just pulled from with an asterisk. And then we're going to say letters, and we're going to take index plus 1. And I want to go to the end of that string, so I want a colon with no value after that. When that's all said and done, we're going to print our randomly ordered letters. And again, I want to do this whole thing in a loop, so I'm going to add for x equals, for x in range, and we'll do 0 to 10. That's going to give us 10 of these. I'm going to indent these. And let's test. Actually, before we do that, let's get rid of or comment this out. We've already seen that that works. So I'm going to comment out that region, and let's run. Oh, we got an error here. Somewhere I misspelled random. Right there, I misspelled random. So Control S to save, F5, and there we go. There are our 10 strings with the letters A through L in random order with no letter being repeated. If I wanted to do all the letters A through Z, well, I can do that. I'm just going to add the letters to my string of letters. Everything else numerically is based on the length of that string, so I don't need to change anything. Let's just run this. And there then are our 10 strings, the letters A through Z, each one occurring in every string, but no duplicate letters. You begin to see how the random class works really well with using loops to generate things in a sequence.